Hi there, Wildcats. So in your geometry class today, we'll be going to discuss the angles and parallel lines. When a transversal intersect two or more lines in the plane, a series of angles are formed. Certain pairs of angles are given specific names based upon their locations in relation to the lines. These specific names may be used whether the lines involved are parallel or not parallel. So you have to expect these terms. These are the name given to pairs of angles. It can be alternate interior angles, alternate exterior angles, corresponding angles, same side interior angles, and same side exterior angles. And also, we will review on your vertical angles because we are going to use vertical angles also as a special angle formed between a parallel lines and a transversal. Now let's examine these pairs of angle in relation to parallel lines. All right, so first type of the angles that we'll be using will be your alternate interior angle. So we have alternate interior angle. Of course, it's very clear that the name itself, it says there interior. The location is, of course, the inside or the interior. So location is inside your parallel lines. So the theorem involves in here, if two parallel lines are cut by a transversal, okay, so these two, when you see this symbol, that means that these two are parallel lines. A parallel lines never, there's no intersection, they never intersect. And this line here, who cut your parallel line, is what we call now your transversal line. Right? So when parallel lines cut by a transversal, they will form a special angles, and one of that special angle is what we call now your alternate interior angle. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent, meaning they have the same measurement. Okay, congruent is denoted by an equal sign with a wavy on top of it. So that is how we denote your congruent. Now, Mr., where are the alternate interior angles located? Again, alternate interior angles are located inside your parallel line. So one, I'm going to use green so that you can see. One will be alternate interior angles here will be angle 1, okay, and angle 2. So they have the same color, meaning angle 1 and angle 2 are congruent. Another one is we have angle 3 and angle 4. They are inside your parallel line and they are alternating. All right. Next type would be alternate the first one is interior. This one it's basically would be exterior. Exterior means outside. So alternate exterior angle Location, of course, is exterior. There you go. All right. So where are the exterior? It's outside your parallel line. I'm going to use another color here. Maybe I can use yellow. Alternate exterior angles are 5. So angle 5 is congruent to angle 6, and angle 7, maybe I can choose another color here, sorry about that, right? So angle 7, the brown one, is congruent to angle 8. Thus, your alternate exterior angle, your alternate exterior angle are congruent. Okay? So your alternate exterior angles are congruent. So that's the second type. The third type that we have in here is we have same side. So same side, you have same side interior. Same side interior angles. The location, of course, it's interior. It's inside your parallel line. And your same side interior. That's interior angle. Your same side interior angles are supplementary. Sorry. Supplementary. Meaning, if you add this angles, two angles will they sum up with 180 degrees. Again, we need I'm discussing this one because once we solve a measurement of angle using algebra, we'll be using this relationship so that it will be a lot easier for us to solve the given angle measure, right? So same side interior angles are supplementary, meaning if you add the two angles will give you 180 degrees. So where are the same side interior angle? Same side interior, it's angle 9 and angle 10. So these are supplementary. So if the measurement of angle 10 is 100, then angle 9 will be 80. Another one is we have angle 11 and angle 12. Right? So they are now supplementary. Okay? So that is your same side interior angle. All right, next type of angle will be same side exterior. Same side exterior angle. So your same side exterior angle is located at outside exterior, meaning exterior, sorry. So it's outside, meaning it's because of the exterior work. So student, if a parallel lines are cut by a transversal, then your same side exterior angles are, okay, same side exterior angles are also supplementary. So where are our same side exterior? So same side exterior would be this angle here, we have, let us say, angle 12 and angle 13. And then we also have angle 14 and angle 15. So meaning if you add them together, will give you 180 degrees. Remember your supplementary angles, so you give, they will give you 180 degrees. And the other relationship that we have is your corresponding angles. So corresponding angles okay, so the location is one of the angle is interior and the other one will be exterior. Okay, so they are corresponding to each other, meaning they are next to each other. Or if it is not next, it's the other way around. Okay, so if two parallel lines are cut by a transversal, then corresponding angles your corresponding angles are congruent. So the corresponding angles are congruent. So meaning corresponding angles, these are consecutive. So they are consecutive. So one of which will be interior and one of which will be exterior. So an example of this one would be 15. This is angle 16 and angle 17 are corresponding. Okay. Angle 18 and angle 19 are corresponding. And then we also have angle 20 and 21 are corresponding. And also we have 22 and 23 are corresponding. So you see, I'm making use of different colors so you can see where are the corresponding angles. Okay, again, corresponding angles are always congruent. Okay, and the last one, of course, we will review on this one. We have your type. It's just only a review. I will not put the location there already. So this is a review. Type is a vertical line or vertical angle. Sorry, vertical angles. Okay, so vertical angles are always congruent. So vertical sorry, I can just erase this one because vertical angle, it's just only a review for you guys because we already did that. Your vertical angle, it has its own theorem that vertical angles are always congruent. Okay, so what are the vertical angles? Let's say we end up 23, so we have 24 and 25 are vertical angles. Okay, 26 and 27 are vertical angle, meaning these two are congruent. 25 are congruent. We also have 28 and 29 are vertical angles, and of course we have 30, angle 30 and angle 31 are vertical angles. I made use of different colors so you can see who are partners in there. So those are your vertical angles. So it's just only a review for your vertical angles. Now the most important there is that I want you to memorize, I want you to master those relationships in terms of parallel lines, and that parallel lines was cut by a transversal because we'll be using those relationships to solve a measurement of an angle. All right, so our first example using those relationships in solving measurement of angle using algebra is this: find the missing variable. of course, we'll be solving for the value of x and for the value of y. So as what I have said, we have to use the relationships of your angle when a parallel lines is cut by parallel lines are cut by transversal. All right, so we start with, of course, finding the relationship. This one, 75 and your 5x minus 10. If you go back on this video, they are same side, okay, same side interior. Because they are same side interior, therefore, these are supplementary. Okay? If they are supplementary, meaning if you add them together, they will sum up to 180 degrees. So I can start from there. 75. So we are now solving for the value of x using this relationship. Okay, Mr. Why don't you use this one as a vertical angle? Take note, we have x here and we have y. So they are different variables. So we need to have the value of x first before you can use the vertical angle. All right. So what are we going to do now is we have 75 plus 5x minus 10 is equal to 180 degrees. So we set up that equation because as a support, same side interior angles as a support is the theorem for same side interior angles are supplementary, right? So we have 75 minus 10 give you 5x plus 65, okay, is equal now to 180 degrees. No, this is 60, sorry. 75 minus 10, that's 65. All right. And then, of course, I'm going to subtract 65 both sides. That will give me 5x. Okay, 5x is equal to 115. And then I'm going to divide both sides by 5. That will cancel out. So my x value is equal now to 23. Ooh, LeBron James on the house. All right. So if I'm going to plug in, okay, if I'm going to plug in 23 to my x, I can now solve for this one, for this angle here. How? They are vertical angles, meaning they are equal. Okay, so when you said they are vertical angles, and of course they are equal, I could say that 5x minus 10 is equal now to 10y minus 25. We set up that way because we know already the value of your x, which is 23. So I'm going to plug in 23 to my x. All right, so 23 will go here. So that's 23. And then minus 10 is equal to 10y minus 25. So what are we trying to do is we are solving for the value of y. So 5 times 23, sorry, that's 23. I mess up again there. Yoo-hoo. There you go. So this must be 23. So 5 times 23 will give me 115 minus 10 is equal to 10y minus 25. 115 minus 10 will give me 105 is equal now to 10y minus 25. I will add 25 both sides to isolate my y plus 25. This will be cancelled out. So I have 130 is equal now to 10y. And I'm going to divide both sides by, right, 10. So what's the value of y? It's 13. So 13 is equal to y, or y is equal to 13. So we solve the problem. We find the two missing variable there, where x is equal to 23 and y is equal to 13. What makes our work easy? It's because we know the theorem behind those relationship of the given angles in our problem, right? Next example here. So first is identify there are three parallel lines there. It was cut by just one transversal line. And let's do, in here, we have to find the value of x and the value of y. And these are corresponding angles, but we need to find one of the variable first. So one of the easiest way to find your variable x. So we'll be using this alternate. The relationship is alternate interior angles. Now to set up our equation, because we already identify its alternate interior angles, you go back what theorem involves your alternate interior angles. It says there, your alternate interior angles are congruent. So they are congruent. So I'm going to set up this one as an equal. So 60 is equal now to 3x plus 15. So what I'm going to do now is subtract 15 both sides. So I'm going to subtract 15, subtract 15. So what will happen? We have, this is 3x is equal now to 45. I'm going to divide both sides by 3. That will give me an answer of 45 divided by 3 is 15. Sorry about that. Let's change the color to have a consistency. So 45, that will give us 15. So 15 is equal to x. There you go. Bear with me. So x is equal to 15. Now that we have the value of x, then we can now solve for these two, meaning they are same side or corresponding angles. They are corresponding angles. Therefore, go back and what does it say? So when they are corresponding, they are also, corresponding angles are also congruent, meaning they have the same measure. So I can set up as 3x plus 15 is equal to negative 5y minus 10. All right, so we have the value of x, which is 15. So I'll just plug that in. So 3 times, okay, the value of x, which is 15, I'll put it here. So that's 15. So I plug that in. And then we have plus 15 is equal to negative 5y minus 10. Now, doing the math here, 3 times 15 is 45 plus 15 is equal to negative 5y minus 10. So this is 45 plus 15, that is 60, is equal to negative 5y minus 10. I will add 10 both sides, okay, plus 10. This will give me, we have 70 is equal to negative 5y, okay? In some cases, just like this one, you will have a negative answer for the variable. It's okay to have a negative answer on this variable, just only for the variable, because once you plug in, it will become positive. Once you plug in the value of y in here, so it will become the measurement of the angle is positive. Okay, we are just making sure that the measurement of the angle, I'm pertaining to the measurement of the angle, it always be positive. So I'm going to divide this one by -5, -5, -5. This will be canceled out. So the value of y will be -14 is equal to y. So when you try to plug that in, -14y, it will give you a positive answer, which is 60. Right? So we're done. So we have the value of x and the value of y. All right. So we're ready for the next example. Next example is we have this. All right. And sometimes if you see the relationship of these two angles, it's like, Mr. They are not related to each other. However, you can use their other relationships to solve that. So let us say this angle here, 102, can be the same as this angle here, which is this angle here is also 102. From there, because they are vertical, and now this angle and this angle are same side, okay, same side interior. So you can now do same side interior are supplementary, okay? So what are we going to do now is you add them. So 102 plus 2x plus 12 is equal to 180. Again, what I did is that I made use of more than two relationship, okay, to solve this problem. One is the vertical angle. You can use other relationship as long as it will narrow down your ways to solve the problem. In this case, I made use of your vertical. Is it possible to use a corresponding angles on this side? Yes, you can use that. All right. So for me, it's a lot easier to use your vertical angle because it is they are always congruent. What I'm going to do now is 102 plus 12 because these are like terms. It will give me 114 plus 2x is equal to 180. So I'm going to subtract 114 both sides. Therefore, we only have, when we isolate that, we have 2x is equal to 66. And then you divide this one by, of course, by the coefficient of x, which is 2. And then, of course, 2 will be canceled out here. So x is equal to 33. There you go. Okay. So that is how we solve angle measure using algebra, at the same time using the special relationship of this angle. Now, to summarize the discussion that we have in here, we have your alternate interior angles, alternate exterior angles, same side interior angles, same side exterior angles, and then we have corresponding angles, and of course our favorite vertical angles. See you next time, guys, and have a good day. Bye-bye.